Hello, I'm back with another problem from my previous quiz B on series and sequences. For this problem, we're looking for the sum of this infinite series where the nth term is given by n squared or 1 over n squared minus 10n plus 24 running from n equals 7 to infinity. So the summand is a rational function. So whenever you're given with this one, often the result is something that involves telescoping sums. To do that, we will rewrite the summand into its partial fractions. So we have here 1 over n squared minus 10n plus 24. We can factor out the denominator as n minus 4 times n minus 6. Now, using the method of partial fractions, we know that this can be written as a over n minus 4 plus b over n minus 6. So this thing here is equal to that thing there. And if we multiply both sides by the denominator, then we'll get 1 equals a times n minus 6 plus b times n plus 4. Oops, n minus 4. So it's just a matter of solving for the coefficients a and b. We do that by substituting the values that make the coefficients or the n terms 0. Let's say n equals 6. When n equals 6, this term here becomes 0. So we have 1 equals 0 plus b times 6 minus 4, and that's equal to 2b. This means that b is equal to 1/2. N equals 4, we get 1 equals a times 4 minus 6 plus 0 equals negative 2a, which means that a is equal to negative 1/2. Therefore, we have here 1 over n squared minus 10n plus 24 equals 1/2 times 1 over n minus, the positive 1 is the b, so it's n minus 6, then minus 1/2 times 1 over n minus 4. Of course, we can factor out the 1/2, so it becomes 1/2 times 1 over n minus 6 minus 1 over n minus 4. So this is the partially decomposed or partial fraction decomposition of the given summand. There's actually a trick here. Whenever you have something like n minus something times n over something, n minus something in the denominator, the trick here is always 1 over the larger one of them, in this case it's 6, minus 4 times the quantity of 1 over n minus the bigger one minus 1 over n minus the smaller one. It actually doesn't matter which order you choose. It's just that I prefer getting the larger one because it's going to give you a positive coefficient. Okay? So just another example. For example, if you have 1 over n plus 5 times n minus 1, the bigger one of them is this one, the positive 1, because this n plus 5 here will give negative 5. Get it? So the partial fraction decomposition of that is 1 over 1 minus negative 5 times 1 over n minus 1 minus 1 over n plus 5. Okay? Anyway, going back to the problem we have at hand, the actual important part here is that we have decomposed the summand into its partial fractions. So we have here the sum of the summand from n equals 7 to infinity. We have a factor of 1/2, so we can take that out. 1 over n minus 6 minus 1 over n minus 4. If you write the first few terms of that, we get 1 over 7 minus 6, that's 1 over 1, minus 1 over 7 minus 4, 1 over 3. Then at n equals 8, that's 1 over 8 minus 6, that's 2, minus 1 over 8 minus 4 is 4, and so on. We do it until we get a few more terms. So 1/3 minus 1/5 plus 1/4 minus 1 over 6 plus 1 over 5 minus 1 over 7, and so on. Now we notice that starting from this 1/4 here, actually the 1/3, starting from the 1/3, we can cancel out the next few terms. So the 1/5 is cancelled here. The 1/6 will be cancelled out by the next term. The 1 over 7 will be cancelled out by the next term, which means that this thing here will only give us 1 plus 1/2 minus the last term. Let's call that 1 over k minus 4. Actually, we're forgetting here the 1/2 outside, so let's just put that back. Oops, let's put that back there. So there's a 1/2 here, and so on. So in the language of calculus, we say that the partial sum here is 1/2 times 1 plus 1/2 minus 1 over k minus 4. To get the sum of the series, we take the limit as s sub k as k approaches infinity. 1 plus 1/2 minus 1 over k minus 4. Now this thing here is constant, so that just becomes 1 plus 1/2, and then this one is 1 over k minus 4. The denominator of that when k approaches infinity becomes so big that it diminishes to effectively 0. So this sum here is equal to 1/2 times 3/2 or 3 over 4. I just made this part, or I just mentioned this part because I want to be a little bit more formal about it. But once in your competition setting, you don't have to do this exact thing I did. Just go back here and note that the end here, the end term will approach 0. Otherwise, if it does not approach 0, then the series will not converge. Okay? So the answer here is 3/4. If we go back to the first part, we say that this is 3/4, and that's our final answer. I hope you learned something from this. Thank you for watching, and see you on the next one. Bye-bye!